Collin, have you seen the new W2A series of strain gauges?
No, I haven't. What is that?
It's based on a CEA series of gauge, and it's got an environmental protection that's already put on it, so it's called a waterproof gauge. And today I'm going to help you with bonding one of these things using our M-Bond AE10.
All right.
You good with that?
Yeah, sure. Sounds good.
Excellent. Okay. So let's start off with surface preparation. What's the first thing we do? We're going to degrease it. Let's take some of the CSM3 and a gauze sponge and degrease the beam. All right. And then the next step is we're going to take the 320 grit, or no, wait a minute, this is the pre-tumbled beam, so we're going to start with a 400 grit. Okay. The surface on this doesn't require the 320 that you'd normally use on an unprepared beam. So we're going to dry or wet a braid with a conditioner A and the 400 grit silicon carbide abrasive paper, SCP-3. So he's flooding the area with the conditioner A, the mild phosphoric acid solution, and he's scrubbing it 10 or 12 strokes with the 400 grit silicon carbide abrasive paper. This is loosening any surface contamination or corrosion, and the conditioner A is an etchant, so it further removes any surface contamination and or oxidization. Using a single wiping motion, he's going to dry the surface of the beam. And now he's going to use the conditioner A and a cotton tip applicator, and he's going to scrub the surface with that mild phosphoric acid solution. We're going to absorb the leftover granular stuff that's left behind and get rid of it. Notice how the cotton tip applicator is turning nice dark gray. That's all the aluminum stuff that he's peeling away. Take a single gauze sponge, fold it into quarters, and with a single wiping motion absorb the material. And now we need to do a neutralizer 5A. We're going to stop the corrosive nature of the conditioner A, and we're going to slip over to the neutralizer 5A to bring the pH to the proper pH for bonding. Most materials do not like to bond to an acidic surface, and so our adhesive systems, we design them to be used with the neutralizer 5A as the last step. It also has a little bit of detergent in it to help wet the surface. Last step would be to use a gauze sponge, fold it into quarters, and dry the surface of your beam. All right, now let's set this puppy off to the side. Well, we finished our surface preparation. Now we need to burnish an alignment mark. And so Collin, because of the nature of the backing of this gauge, it's a little opaque, is going to use a dental probe and the elbow of the dental probe to burnish an alignment mark. And he's going to use the glass plate as a straight edge, just for demonstration purposes. Anything that's straight. And he pulls it across a couple of times. And you can see that nice little shiny line. Now, when we finish mixing the adhesive, what we'll do is we'll take this and we'll lay it over the top of that alignment mark and then bond it in place. So just for reference there, that's what we're about to do. Okay, Collin, go ahead and mix up the AE10.
Okay.
AE10 resin and type 10 curing agent. The AE10 is recommended because it's superior moisture resistance. You can use M-Bond 200 for short-term installations, but for a long-term installation, we'd probably recommend AE10. He's going to draw up the right amount of curing agent. Dispense it in the jar. Seal up the curing agent because it's very hygroscopic. And he's going to stir it for 5 full minutes. This will thoroughly mix it and keep the exothermic reaction evenly distributed within the adhesive system while we're mixing it. Okay, Collin, have you finished your 5 minutes of mix time?
Yes, sir. 5 minutes.
Very good. Now, if we were going to use this material immediately, the minimum cure time and that sort of thing at 75 degrees Fahrenheit, we'd let it sit for another 5 minutes to let the exothermic reaction get rolling pretty good. But because we're going to leave this overnight, go ahead and take your stirring rod out, He's going to clean that off. Any unmixed curing agent or resin, you want to make sure it's all gone. And now we have the backing of the gauge, and I'm going to hold this for Collin because it's a two-man operation here. He's going to take the adhesive and he's going to smear it onto the backing of the gauge. Now be careful not to touch the working surface or the bonding surface because you'll contaminate it with your finger oils. And he's getting a nice even coating, just kind of squeegeeing it around. And now he's fully wetted that. He's now going to wet the surface of the beam where the gauge is going to land. And the reason we do this is we want to make sure we have not a starved bond line. If you don't wet both surfaces, there's the potential for a starved bond line. So now we're going to lay this down over the top of our alignment. Follow with a silicone gum pad with an aluminum backing plate. Ooh, this is kind of squeezy. And then we'll clamp it up. And we want to look down this and make sure our backing plate and our aluminum beam are parallel to one another. We want to have nice even clamping pressure. And now we just let it sit overnight. All right, Collin, let's teach it how to swim. Drop it in the water. Let's see how good she is. Tiny bit of thermal output change there, but look at that. Rock stable at 2 microstrain. I could balance that out and it would remain stable for the balance of this test. I'm proud of you, Collin.
Yeah.
Your gauge installation passed the swim test.
Awesome.
He can go out without a buddy.